Hello and welcome to our next webinar, Big Data Goes Reactive, with Ankur Mathur and Dana Harrington of Nurun. My name is Laura Masterson. I'm the Community Manager here at Typesafe, and I'm going to be your host for this session. So this is the second part of a three-part series on how Typesafe technologies are used to tackle the challenges that modern retailers may face, ranging from modernizing their legacy architectures to effectively handling concurrency. So this morning we had Gilt present on how Akka is used to handle inventory management. And later today, our partners Tomax are going to share how a reactive model helps retailers handle issues like concurrency and real-time data flow. We're going to release all of the recordings at the same time, so you can look for those within a day or so. If you have questions throughout the presentation, just insert those into the little chat box on the lower left-hand side of your screen, and I'll do my best to respond to those as we go along, and saving a few of the technical questions for Ankur and Dana for a Q&A at the end. So with that, I'm going to go ahead and hand the floor over to our presenters. Thanks, guys, so much for joining us today.
Thanks, Laura. I'm Ankur Mathur. I'm Dana Harrington. And we're really excited to be here to talk about how we introduced the reactive platform at Walmart Canada and share some of our experiences with you. We're going to start off with a quick introduction, some history and background on the context, and then we'll sort of take you through sort of the high-level architecture decisions that led us towards the re-architecture and using the reactive platform. Then we're going to sort of explain some of the details around our move to functional programming, the challenges, and then hopefully share some useful tips and features that you might find useful. And finally, we'll conclude with some overall impressions and experiences, and share some outlook of where we see the retail space going, as well as the role of reactive within that. So a little bit about Nurun. We're a global design and technology consultancy, and we have over 1,200 employees around the world. The Toronto office, where Dana and I work, has largely been focused thus far on the retail and financial services verticals. In introducing Nurun, we also want to sort of give you a little bit of background if you're not familiar with the e-commerce technology space of kind of where we're coming from. So the e-commerce space has been evolving since about 2000 in sort of spurts of growth. We saw a lot of large e-commerce vendors come out in the beginning of the millennium with some fairly standard J2EE type applications that had a very mature domain model, largely driven by database schemas, and very kind of thread per request model based. And well, these were great for large retailers to get into the e-commerce space. They started having some challenges around, first around flexibility of sort of guided navigations, merchandising, and things like that. So around 2005, 2006, Nurun began to work with large retailers in Canada like Home Depot and Sears, and saw an opportunity to introduce some relatively new technology back then around search and merchandising that allowed retailers much more control over the guided navigation flows and designing landing pages and with less development effort. This architecture has been kind of applied very successfully for over 6 years. And then, we found that, there was definitely a cost associated to scaling this up, given that a lot of these large e-commerce platforms do require some high-end server software, etc. So we began to look for alternatives around 2011, 2012. Some of us discovered Scala. We heard about kind of the whole multi-core challenge with having many more cores, and the challenge in having to design for concurrency, etc. So some of us were kind of playing around with this technology when we got introduced to Walmart Canada. So we were brought in around 2012, late 2012, to see if we could help them redesign their incumbent platform, which was based on ATG and Oracle. It was not too different from the platforms we had seen before. It was fairly monolithic. The main challenge they were facing was with their rapidly evolving merchandising needs and the need to be able to customize the site with less effort. And that was familiar domain to you, as I just told you. But so we were pretty convinced that Endeca would help here, and Endeca has since also evolved into giving the merchandisers sort of unprecedented control over designing entire pages and templates, as you'll see shortly. So that was one of the considerations which we thought we had a solution for that problem at least. But then around 2012 holiday season, we saw a huge increase in the load that was received by these servers. As you can see here, the green line is the 2012 peak this is from a blog from Akamai about overall Canadian e-commerce sites, and there was a huge increase, and that resulted in some scalability issues at Walmart Canada as well. Their site went down on 2 important days, so that kind of pushed us further to think about a different architecture. So just to emphasize, these are the retail priorities we're seeing across our clients. There's definitely a need to handle large volumes without a lot of capital expense, and if there is some downtime, we need to be very resilient, and because downtime is measured directly in dollars, there's no debate about that. It's very clearly hurting the bottom line. And then the business requirements change very rapidly. It's a very competitive environment, so it's important to design the system with that in mind as well. So you can see that this ties pretty closely into the reactive manifesto. The need to be responsive, leads to the customer experience and the brand promise. The resilience has been traditionally handled at an infrastructure level with data center failovers and things like that, but then there's definitely a need to pull this down into a lower level at the application component or even code level. And the elasticity, as everyone found out, is very important to handle the peak holiday seasons without investing a whole lot in hardware upfront. And then the message-driven architecture does support all of the above. So with that, let's get into a little bit more on how we arrived at this architecture. So as I was saying, the ATG application was backed by an Oracle database, receiving content and and data from a variety of enterprise sources. We had, Endeca was definitely something that we were going to put in there, and it offered the option of either embedding the application within a J2E app, or that J2E app can offer an out-of-the-box REST API. We chose ACA to be sort of the integration framework or a tool set that we built our integration layer on, because there was definitely a need for highly parallel data pipelines for ingesting all this data into an index. And ACA and the actors model provided a very familiar architecture and paradigm to people who've been working in the integration space and need to deal with sort of message flows. Also, because a lot of these data sources weren't known up front, and a lot of them needed to be it needed to be a rapidly evolving layer. So ACA allows us to do that as well, and we chose Redis as sort of an intermediary persistence and data staging tool, a database technology here. Then, of course, the decision to whether to build the actual web app within Endeca or to actually create another layer was the big one. So, we were convinced through our kind of early POC work that something that's more like an event-driven architecture that doesn't tie up a thread for every request would scale far better than Servlet 2.x, which was what Endeca was at that point. So we decided to put a play layer in front and use the REST API. And the other thing was that Play offered a very nimble and modern developer experience, and that was another kind of pain point with some of these heavy-duty J2E application frameworks. And then finally, their existing UI, which was built on JSPs within ATG, got refactored into a REST API that again spoke JSON to back to Play. So the advantage of this was that the Play layer could be completely stateless. Endeca is stateless as well. So the only session management and state needed to be done within ATG, but we were protecting it from all the traffic that didn't need this session management, and essentially all the customer profile and the checkout related stuff remained in ATG, and everything else was offloaded. So this was a very successful initiative. 1 year later, we launched the site, saw a lot of increase in conversion and a decrease in the page load time. We got an award for the best e-commerce site amongst large retailers in Canada, and most importantly, there were no system outages at all. In fact, during Black Friday, I remember all the Play servers were humming along at about 60 to 70% utilization.
So I'll pick up at this point and talk about the move towards a new platform, a new programming language in Scala, and how we kind of built and really matured a team to work on that. Of course, the majority of developers around had a Java background. It's very difficult to find experienced professional Scala developers, but it gives us a great recruiting tool because the really keen developers are looking for the newest technologies, and that really out to experience new things are on top of this, draws them in, but then we need to build up that experience. Play provided a great platform for that in that it is very familiar from a web framework point of view, your typical MVC patterns there. You can do it in a very Java style. You can write your Scala code in a very sort of direct translation from Java, doing all the mutation and blocking sort of stuff. But there's a nice smooth pathway to building a more functional, idiomatic Scala style and using immutable structures and non-blocking ways of computing. We had to enforce some rules to really get our code moving in the right direction. So here's some of the fundamentals that we really tried to enforce to take advantage of this new platform. One was just simply getting rid of nulls entirely, replacing them with options. This gives you the safety, and it moves towards the idea that your code is really expressing the data that it's manipulating, and not having to worry about whether something is a null is great relief, and having it explicitly in your face that one piece of data may or may not be defined forces you to deal with those situations. So sad path, happy path split up and become very in your face. Vars and mutable state, we've essentially eliminated. They added complexity to the code. We found that a lot of refactorings that dealt with purely vals and not defining variables until we had the data that was to go in them greatly simplifies the code, also makes testing a lot easier. And then moving into taking advantage of the Scala collections, the higher order functions, map, flat map, filter, and in some cases for comprehension, make the code a lot easier to read. And partitioning our code so that we would have our business logic purely functional and as clear and concise as possible, so that we can directly test the pure business logic that should map almost one-to-one back to the business requirements, and then having the side effecting parts separated out. So complicated business logic, purely functional. We can test it in terms of unit tests as inputs go to these outputs, and that's all the code is doing. Lastly, really trying to take advantage of the type system that Scala provides to use strong types to express to the compiler what our meaning was, so that it could come back and tell us when we've done something that it doesn't think makes sense. So really trying to, in general, focus on clear and concise code. You should be able to read the business requirements, the business logic directly from the code. Trying to move, from code with no obvious bugs to code with obviously no bugs whenever possible. Not always possible, but certainly something to strive for. And the types, really using them to express what's going on in the program. Those types should fit exactly with your data, and I'll give a little example of that. The Walmart Canada site gives you two language options, English and French, and that's generally controlled by a little party path coming in the routes. So you get an EN or an FR to determine what page you're going to get. Initially, we were using just a string to pass around this little EN, FR, and then all the code that was conditionally operating on the language would do a match against EN, a match against FR, and of course we have then an infinite number of strings that are neither EN or FR, and we just have to default to something, and that defaulting was happening all over the place. We didn't really know when we were missing or when we had something bad. We could log it, but then you have to dig through logs for that. So it's really simple with Scala to define a custom type that would express this language using basically an algebraic data type pattern. So sealed language trait with English and French being the only options. All our logic can be in terms of pattern matching. If it's English, do this. If it's French, do that. You know exactly what it means. There are no other options for language other than the ones we've defined here. So, consider you could use Boolean. There's two options there. But then, is true English or is true French? It's pretty easy if you're just relying on variable names to have those mixed up. Not to mention the variety of other Booleans that aren't representing English or French. With play, with 3 more lines that I haven't included here, but just a simple 3 lines, you can set up play so that it recognizes and converts to our custom language type directly from the routes file. So E and F are get mapped to English and French, and the entire play application end-to-end is using this language type. It may seem like a small thing, but all these small things add up to code that is, there's a lot more compiler checks that you can depend on, fewer things that you need to worry about when you're trying to track down an issue or trying to introduce some new functionality. The next little section, maybe not so little, we'll talk about some basic tips and some of the features that we've introduced to the site. The first one is, I guess, a simple tip of using futures and actually caching, so caching on heap futures rather than waiting for a request to return data before we add it to the cache. There are some situations in our application where we know that there's going to be a number of requests for the same piece of data coming in at roughly the same time. There are a lot of different ways you can handle that, but the future approach is really simple. Whichever the first one comes in, checks cache, doesn't find a result in there, so it fires off a request, and before that request is completed, it just puts the future into the cache. So the next request coming along can see the check the cache and find that in-flight request, and rather than initiating a new request, can just wait on that existing one. We made a decision to avoid any sort of locking, so it's possible that if you had another request come in before the first one had a chance to cache the future, then you might get 2 requests or whatever, but the odds are pretty low, the cost is pretty low, and the simplicity gained by avoiding locking and the worries associated with that were definitely worth the cost. Next thing I want to talk about is handling JSON. As you saw from the architecture diagram, there's a lot of JSON flying around, both for the web services and for talking to Endeca to get the general layout of a page set up on that end. 2 different ways that Play provides of dealing with JSON content. The first is the case class macro combination, and I've just provided some demo code here to show you how simple that is if you're not familiar with Play. I can define my Scala case class with 1 line in my companion. My macro produces both a method to read and write my Scala class back and forth to JSON, and then my code below is converting to JSON or from JSON for those case classes. One issue that's come up that I'd like to throw out there, if anybody has any ideas on a solution for this, it's so simple to create, to use the macro to create a direct translation from your case class to your JSON objects. The problem is that sometimes you have something that you want 95% default. You just want to kind of override the way that one field or maybe 2 fields are being translated. For example, you might want to translate an optional JSON field to a Scala class that has a default in it. So if it's not there in the JSON, we'll just give it a default value. Or, for example, going the other way, you might have 2 dates in your Scala class, and you want to convert them to strings in JSON in 2 different formats. It seems that the way to do this is basically drop the macros and go back to the regular macro-free way of defining every individual converter for reads and writes for each one of the fields in your class. It's not that bad, but it's so nice to have those macros that it's a little bit painful. It'd be nice to say, I want everything default except I can override this. Had some feeling that maybe shapeless with the case class generic macro might help, but we haven't really had enough time to pursue that and see if that pans out. If anybody has any ideas on that or directions, that'd be really helpful. We'd appreciate that. Back to translating back and forth between JSON. So the other option that came into play was this JSON transformers, and they give you a very lightweight way of maintaining your JSON AST. You're not converting to a native Scala class. And where we're using this mostly is with our web services. Largely, we're getting requests in from the front end, and we're just passing them through to the back-end services, back to ATG primarily. We're getting response from ATG and then passing that through to the front end. Sometimes we have a little bit of augmentation we might do if our response contains, let's say, some SKU IDs, and we want to augment that JSON response with a little bit more data we're pulling from other sources. But by and large, the play code doesn't really need to know about the entire JSON structure of the request and response. The JSON transformers allow us to keep it just as a JS value and target particular areas of that structure to either read or write some additional data in there. The play transformers can be a little challenging if you're not familiar with them. If you're using them and finding you're having a hard time understanding how to get what you want done, there is another project out there that adds another extends the API, I guess you'd say, play JSON zipper. It's available on GitHub and gives you a slightly different API for the JSON transformers. Another issue facing us was for testing, and that was dependency injection. There's a lot of options in Scala from cape pattern or taking things from the Java world like juice. We chose to go with structural types for a balance of lightweight and some static checking, at least for dependency injection at the controller level. We want to create a service module with each request, and we actually needed to have the request header coming in, and we want to use that when we were building up this services module, primarily just for logging. In case something went wrong, we would have all the details of the request in case they were at all relevant. We had a bit of a challenge, though, because the dependency injection would happen at the get controller instance in the global object in play. Unfortunately, at that point, we didn't have our request header anymore. It wasn't part of the parameters passed in. We used a little bit of the trick that might be handy. Those of you out there with a similar problem. In the on-route request, we did have access to the request header, so we used a thread local, actually I think an inheritable one, to initialize our service module there, and then the get controller instance was able to pick up from the thread local our service module and pass it into our controllers to have access to the services. The next feature that I want to talk about is a little bit bigger, and so first I'm going to have to go into a little more details in the half of the play application that deals with talking back and forth between the front end and Deca to give the overall page structure. So what the business user sees on the Walmart side when they're creating a new page is they have an option between a number of templates, maybe a dozen or so, that determine the overall layout of the page. Each template will have a number of zones within it, and the business user can put cartridges in there. So once the business user selects a template, they get their overall layout, and they can start filling in these cartridges. And at this point, we have almost 100 different cartridges that the business user can plop in to customize the content of the page. The role of Indeca is then to fill in the individual details from its product catalog and some rules to control the content we're adding in. Hand that off as a JSON document to Play, and then Play takes that JSON document and turns it into HTML. The structure of the JSON document maps quite directly to the structure of the page that you're going to see. There's a top-level template. There's at the second level, you have your individual zones on the page. And then inside those zones, you have 0 or more cartridges that have been dropped in there. And so it's tantalizingly simple to view this as cartridges are being converted into little snippets of HTML. They're being dropped into a HTML template that is determined by the particular template that the business user has chosen, and it's a really nice, appealing view of what's happening in the code. It's almost but not quite accurate. There's a few other things that we want to deal with, both for correctness and for performance reasons, that unfortunately disrupt our nice, simple picture. One is that we want our cartridges might have some individual custom CSS or some Java code to set up some models, or some Java AMD modules for required JS. And we're going to need to include those on the page for the CSS, and that we really want to put it in the head. Sometimes there's JavaScript that needs to go in the head of the document. So when we render a page, we want to be able to extract out of all the cartridges those requirements. And for the most part, we would like to have our JavaScript setting up models and that not sprinkled throughout the page, but at the bottom of the page, so that our DOM can be rendered and then our scripts can go through and set up whatever they need for the interaction. The last little bit of top-level stuff that we have for the final construction of the page is that we found out that sometimes our Indeca response would come back with some errors, and usually this occurred to some sort of updates were happening. We'd be digging through our JSON document to render it, and we'd find out that a cartridge or two, one of the subqueries had gone wrong, and we ended up with an error message in there. We made a decision at that point that in order to keep the site experience responsive, we were willing to tolerate having perhaps some cartridges that were missing. They would just be blanked out if there were errors in them, in order to get a quick response back to the end user. The end user, if the page didn't make sense because some essential information was missing, would of course reload the page. But what we really wanted to avoid was having a little glitch in our page and ending up caching that in our CDN or in the browser cache, and having that, in the case of the CDN, served up for however long. So we want to be able to signal that something hopefully relatively minor has gone wrong in this page. We'll serve it up this one time, but we're going to retry next time. So we have a little bit of information for cache control. The implementation for this, we used a custom monad for this. It all started out with really that caching problem came up first. At that point, we introduced the monad into this process. Then we had the issue of some of the cartridges need to make service calls out. We didn't want that to be blocking, so we started introducing futures into cartridges. We started having asynchronous rendering process. And then the final step that we've added recently is those JavaScript assets. By using this custom monad, it really simplifies the code that we're mostly writing dealing with cartridges, the HTML, the way the templates render them. And all this plumbing work in terms of that flag to say whether we cache it or not, the CSS, the JavaScript that we occasionally need, can be included in this, our validated builder process. So something that produces an X, it's essentially represented by a future of a tuple of X, a Boolean for whether we're going to cache, and then some resources object. And the monad map and flat map actually handle all of the combining and propagating those validity, the caching flags, and all the resources as we go and build our final document up from the cartridge level upwards. Allows our code to be written in a way that looks like the essential task, which is converting a hierarchical JSON document to a hierarchical HTML document, is basically what the code looks like. When I stand back 5 feet away from the code, what I say is the essential task of the code should be the first things that I see. I should really see that. And the details, this extra plumbing, I want that hidden. I want to deal with it once. I want to deal with it in an abstract way, have it dealt with, and not have all this passing around these objects, this side information all over the place. And that's also quite error prone if I'm manually passing these things around as I'm traversing the document. It's nice to have this map and flat map automatically do it for me. Here's some examples of what the code roughly looks like to see how this view of essentially what's happening and how the map and flat map come into play. So this would be roughly what would happen in the zone of a cartridge where we have a sequence of JSON values, and we're mapping over that sequence with something that's parsing out those cartridges. There's a little bit of a switcheroo around here where we want to switch from a sequence of VB for validated builder cartridges to combining that secondary information to the top level of this sequence. So now one validity and one set of resources for this sequence of cartridges. And basically this VB-seq is essentially the equivalent as the future sequence for the validated builder monad. At the template level, we built up a bunch of cartridges that are now validated builders of sequences of cartridges. We can use for comprehensions to put those all together into a cartridge, which is now a validated builder for that template. And that for comprehension, the little left arrows, flat translating to left to flat maps are taking care of all of our plumbing for us, letting us see really what's our essentials of the code. And finally, it all comes together using another for comprehension. I can pull these pieces of my final top-level product, my template, the actual HTML content of that, pull out the resources that I've accumulated, pull out that little flag to tell me whether I should cache it or not, and put them all back together. So I'm going to inject my resources into the appropriate places. I'm going to check to see whether I should be caching this, and let's say either return the result as is or add some headers that communicate upstream that this particular response shouldn't be cached. The final tip that I want to talk about is something that we're just getting into now, which is the idea of having dynamic configuration in Play application. We want to be able to, without taking a server down, enable services or disable services and site features in response to a variety of conditions, or possibly change the endpoints of services on the fly. With the Play default configuration API, the hook-on API, when you make a configuration change, you have to restart the server to see any of those changes. So what our system does, it sends around configuration deltas as JSON objects. It's with the Play hook-on API, you can translate back and forth between JSON, so you can send that over the wire from some back-end services. Play then verifies those changes. It tries to initialize the services with the updated configuration. If, let's say, that were to throw an exception, then Play would not want to use that configuration change and probably complain back to the service that's updating that, saying that there's something wrong with this configuration change. Proceed with what it had before. But to keep things simple from the point of view of an individual request going through the Play system, we want to keep that configuration constant. If a particular service was available at the start of that request, partway through that request, it shouldn't suddenly disappear. So from an individual request, it sees a snapshot of that configuration. It looks just like the regular situation where the configuration never changes. It only changes from one request to the next. And we're reusing the same Play API for configuration, so we don't really have to change very much of our code, only the particular configuration object it's pointing to. Jump into now some overall experience impressions working with Play and ACA Typesafe platform. One thing that really stands out for me is the flexibility of these tools, and it feels really good to never have to say no to the client because there's technical limitations with the tools you're using. Really, we haven't encountered a situation where we couldn't do something. From a lot of our code, we're taking advantage of concurrency, parallelism, both in Play and ACA. I mentioned the cartridges in Play are in principle all being resolved in parallel because some of them may be making web requests out to get further content. It's surprising how few headaches there have been dealing with that kind of concurrency, and mostly those have come up with dealing with external systems. No worries about race conditions and deadlocks. Works amazingly well. And finally, for me, the ability to do really aggressive refactorings to support new functionality, changes in business requirements, by having expressed in our types exactly what we are trying to do to the compiler can tell us when we messed up. So let's say if we were to add a new language to the site, let's say we want to add Cantonese to the site, we add an additional language option. We try and catch every place and add handling for that. The compiler is going to tell us, hey, you missed this particular place in your pattern match. You haven't handled your new language.
Yeah, just to add to that, I'd say that it was so refreshing to move to a platform that was evolving so rapidly. It felt modern. It naturally embraced things like behavior-driven development and just provides a lot of a really attractive and appealing environment for the team to work on and grow. So finally, I just want to share some pretty much my personal outlook towards where we see retail going and how we see reactive playing a role here. So even if there isn't a completely widespread adoption of Scala in the enterprise development space, from a as wide perhaps as Spring or Java, we definitely see this being a perfect environment to build products and frameworks in. And we see a new breed of products coming out with a reactive core. There are already a lot of really interesting middleware distributed messaging systems like Kafka and Samza out there. There's a great push across the industry on cross-channel customer engagement. And SpendGo is one that there was recently a case study on that. They're sort of bringing really aggressive innovation at the point of sale and introducing loyalty programs around that. And there's definitely a lot of opportunity in that space because all the retailers want to merge their brick and mortar customer databases with their online customer databases. There's of course a huge buzz around how Spark has taken over the big data space and streaming data and a lot of machine intelligence and machine learning platforms are coming out that make this kind of previously niche area accessible to the larger technical community. Things like Prediction.io and Harpoon from Ergotech. There's the guys behind Play 2.0 have come up with Prismic.io, which is an excellent new approach to content as a service in lieu of traditional CMS. And that's very important in the retail space. I think we've spent a good part of a decade trying to merge content management and e-commerce, and there's definitely room for innovation in that area still. Back end of the service, recently hear about Really.io, which takes an interesting approach to exposing a sort of a graph data model directly to the front end. We've worked on the responsive UI, but there's certain limitations you come up against, especially in terms of performance on the front end, which require some server-side support. So there's a new kind of area of research called REST, which is responsive UIs with server-side support. And this is another area where we've started making some inroads with some of our in-store technology, kiosks and such, which have radically different aspect ratios and viewports, and using some server-side detection of viewports and things like that. And I just want to mention, Scaloid is a great library for reducing the verbosity in Android code. So there's impacts all around that retail could benefit from. And of course, there's the whole location-aware in-store technology, which is and the Internet of Things and the whole industrial internet, which is bound to have a huge impact on inventory management and just the amount of data that needs to be analyzed in real time. So all these are great areas to expand into. That's all we had to share from our side. We'll take some questions now. Laura, if you want to moderate those.
Absolutely. Thanks, guys, for presenting. First question was rather early on in the session, so it was whether or not Indica still remains a bottleneck because search is so important in an e-commerce website. He was suggesting you might want to improve upon that part of the architecture. I don't know if you have any comments on that.
Yeah, that's an interesting question. I mean, given that it is kind of a proprietary API that doesn't lend itself too much to extending and making it more asynchronous, the honest answer is we try to do the least possible amount of heavy lifting in that assembler API, which still runs on a Servlet 2.x container. We're hoping that the next release will have kind of an async treatment at that layer, which would definitely alleviate some of that. But do keep in mind that Indica is still stateless. There's no overhead of say session replication or things like that. So it still performs fairly well in that way. We do have a layer of caching between Play and Indica that helps offload some of that lag. I'll just reach out to the next few questions. So how long it took us? It was the entire project the majority of the development was done in around 6 months, if I'm not mistaken. And I can't really share the size of the team in terms of, it's a kind of a loaded question because, there was a lot of front-end work that was sort of orthogonal to this move to reactive. And, of course, like if you look at the responsive UI, there's a whole lot of front-end work that went into it. So even though our play and ACA team was, in the 10 to 20 dev range, there was a much larger team working on the front end as well. And in terms of migrating, operationally, we did run the 2 sites in parallel for a little while, but it was a very rapid cutover using our CDN to, sort of pinning people to the new site, sort of a lottery, and then, gradually rolling it over. I believe we did it over a weekend or something like that. So it was pretty rapid, and of course we were ready to roll it back in case we ran into issues, but that didn't happen. Next question is, do you use ACA clustering? No, not at the moment. Our integration layer has some sort of manually devised clustering, partly because we wrote a large part of this code before ACA clustering came out. So we do some some master-slave type thing within our integration layer through Redis, but we don't actually use the ACA clustering feature yet. But that's something we have in mind.
I'll tackle the next one here. So the question is, did Java team members switch to Scala Play and new concepts? So how easy was the transition? Yeah, like I said, most of the people coming in on the Scala team had most of their experience in Java. Generally speaking, they had done a lot of Scala on the side in their free time and had a real passion for it. So they already knew the language reasonably well. It was just a matter of, as I talked to earlier, kind of lots of code review and enforcing those rules and stylistic concerns. It really wasn't that difficult. In fact, there are a few teams that are not using Scala that are really interested in it, given how easy and productive, easy it was to make transition and productive it's been.
Great. There was a next question about, could you see Prismic IO for product information management as well?
Not in my mind. It seems like, at least what I've seen of it, it seems very much geared towards kind of content. This has a writing room, and sort of, we can definitely use it for vendor-facing tool for writing out things like DIY guides and things like that. But product information management tends to be a very specialized space that there are already some strong players in.
Yeah. Okay. Next question was, what mechanism or pattern are you using to cache futures?
So it's pretty simple. So this really only works for on-heap caching because, of course, the future needs to be updated once it's completed. So with EH-cache, we would on-heap caching. Simply, when you've done your request, you get the future for the response. You put that onto the cache. The only little hitch that I might add in there is if your future happens to fail, so you get back instead of a success, you get back a failure. You want to tie into the future and remove that failure from the cache so that subsequent requests are not all just immediately getting back a failure. You'll retry that again.
Got it. Okay, cool. And I think the last question here is, how do you implement the e-commerce service like the order service or promotion service, in a reactive way? Do you use some open source framework based on Agar Play, or do you implement each service from zero?
I can start, and then you can add if you have any. And the truth is that a lot of these kind of core transactional services are not written in a reactive way from ground up. We are using the ATG REST API, like I mentioned earlier. So these are still running in the J2EE platform. The only difference is that we are calling these through Play. So, you know, internal to Play, we have service calls that are, of course, non-blocking, etc. But once the service request is made, these web services are consuming an ATG thread.
So I'll just add to that. For our services, generally we're using circuit breakers that handle, so that there's a ACA, I think it's ACA patterns circuit breaker that lets you wrap a future in such a way that if requests start coming back in beyond a certain say service limit, then and you get a successive number that you can configure of slow responses, you can start to fail fast that to give the service behind a chance to catch up. So rather than really just continuing to hammer on the server, seeing the responses get slower and slower, you just fail fast, give it a chance to catch up, and then periodically retry that.
Great. Well, I hope that answered everyone's questions. And wanted to thank you again, Ankur and Dana, for presenting today. Great job. And thanks for all for attending. So if you all are joining us for the final session today, and it starts in about an hour, it's going to be with our friends over at Tomax. I hope to see you all back online for that. Otherwise, please join us for future webinars, and we will see you soon. Bye.
Thanks.
Thank you.